Hello and welcome back to the lecture on applied econometrics, and we have been talking about dummy variable. Now we have seen till now we have spoken about intercept dummy, and previously we have spoken about the equations for male, female, and like different categories of if we have dummy variables, so we can actually have equations for different categories of dummy variable, and these equations we have seen we can actually call them reduced form of equations. So essentially what is happening here is that in one equation, if I have say male, female, I am sort of boxing them in one equation. So in one equation, I have a full population equation, so like full sample equation where I have both male and female. I can actually unbox it. I can have an equation for female. I can unbox it and I can have an equation for male. Now if I have another dummy, for example sector, so it could be rural and urban, and I can have, if I unbox it, I can have an equation for the people who are in the rural area, and I can also have equation for people who are in the urban area. And with that, if I further include, let's say, social group, so I can have male, female, I can have rural, urban, I can have the equation for SC, ST, OBC and general, right? So in one equation, if you bring all these dummy variables together, you can actually, include all these different equations. Of course, you are making some assumptions about the slope. So in all the equations, you are assuming the slopes are constant. But then at that cost, what you are getting is within one equation, you can actually get so many different equations. And because you are able to sort of capture all these different possibilities in one equation, we often call, by running a dummy variable, we often call reduced form of equation. Okay. Now let us try to sort of explain the reduced form of equation a little further, and we have already have some notion about how it works. So let us just open a new data set to see how we can really get the reduced form of equation. So let's say I want to open another data file that is on US population survey, and I already have this data here, and I will have import first row as variable name. So I get the data set here and I can see the data set here. So I have like this data set where wage, I have a dummy variable called female. I have a dummy variable called non-white. So already the values of the dummy variables are assigned as 0 and 1. So we don't have to do anything here. And if someone is white, someone is non-white, is going to be 1. Someone is white is going to be 0. And someone is a union member is going to be 1, someone is not a union member is going to be 0. Then we have a quantitative variable, education, experience and age, let's say. And there are some other variables we don't need to bother really. So let's first run a regression equation with all these different variables, okay? And I also, here there is the regression equation. I have to regress wage, and our independent variables are female, non-white, union, education and experience. And if I run this regression equation, I have already imported the data, so I can run the regression equation. And if I run it, so I get this table, okay, this regression table. So I have all these different variables here, all right. Now, how do I really interpret? So how do I really now unbox the, unbox multiple equations from this one reduced form of equation? So let's say if I want to get, say, wage for, let's say I want to get the wage for white male who are not in the union, non-union, okay. So I'll just create different cases, white male non-union. Or I want to get, let's say, white female non-union, all right. Then I may want to get the case for, let's say, non-white male non-union. Or I may want to get a case where I want white male union. So all these possible cases I want to sort of understand using this one equation, okay. And how do I do that? I will do that, let's say I will get the equation here. So what is my equation going to be? The reduced form equation is going to be 1.37 into education, y is equal to 1.37 into edu, 0.166 experience, and then you have female is minus 3.07 plus of it's minus 3.07 minus 3.07 into female, all right. And then I have non-white minus of 1.56 non-white minus of 1.56 non-white, and then I have 1.09 union plus of 1.09 union, and there is a constant term minus of 7.2, let's say minus 7.2. Now let's go back to our first case, okay. Our first case was that I want the wage for white male non-union, okay. So we'll use a different colors, too boring to have one color. So for case 1, white male non-union, white male. So if it is a white, so my non-white is equal to 0, so this is going to be 0. If it is a male, the female is going to be 0, so this is going to be 0. And non-union, if non-union, union is going to be 0, so that is again going to be 0. So white male non-union, white male non-union is going to be, so y for white male non-union is going to be only this 1.37 edu minus 0.166 experience. This is equal to 0, the female is equal to 0, non-white is equal to 0, union is equal to 0. So all these terms are going to be 0 minus 7.2, okay. If I want to go for the second case, where I have only change is from the first equation to second equation, I have from male to female. So all I have to do is that when it is female, so my union is going to be 0 and my non-white is going to be 0. Only value I'll have for female, so I'll have to put 1 for female. So the y, let's say y white female non-union is going to be 1.37 edu minus 0.166 experience. Now for female, now I have a value equal to 1, so that means I have to add minus of 3.07 here, minus of 3.07 and minus of 7.2, all right. So that is how I get my second equation. Now if I want to get my third equation, I wanted to have non-white male non-union. So y, let's say y non-white male non-union. So it is non-union. So it is going to be, in the previous equation I have 1.37 edu, then experience, because it is male, so female is going to be 0, and because it is non-white, now I have the dummy for non-white, that is going to be 1, so I will have value for this, so it is going to be minus of 1.56, and non-union, so union is going to be 0, so I don't need to bother about this particular variable. So it is going to be 1.37 edu and then plus 0.166 experience, then is male, so female is going to be 0, so and the next term is non-white, that is going to be 1 minus of 1.56, and then I will have my union term, because it is non-union, so it is 0, and then I have the constant term is equal to minus of 7.2. So that's going to be the reduced form equation. What was the last case we had? We had white male union. We had white male union. So let's write down what we want is white male union, and that is going to be, so my white, so non-white is going to be 0, male, the female is going to be 0, union, so it is going to be 1, okay. So then what I will have is 1.37 edu plus of 0.166 experience, and the only thing that will remain is the union, because we have included white male. So if it is a white, so non-white is going to be 0 and female is going to be 0, only union term will be there, so which is 1.09. So if I add, it is going to be 1.09 and the constant term is 7.2. Now let's say if I wanted to get, let's say, another case, Y, let's say non-white male union. Let's say this is, we change two, we have, value is equal to 1 for two different dummies. So here what I'll have is, so I'll have the value for non-white and I'll have value for the union, right? But I'll not have any value for female. So it is going to be, so 1.37 edu plus 0.166 experience, and then I will have, because it is male, so no value for female, and if it is non-white, because it is non-white, so non-white is going to be 1, so then I am going to have, so it's not a plus, it's going to be minus 1.56 because it is a non-white, and then I have a union, right? So this is going to be again 1, so 1.09, this is going to be 1.09, and then of course I have the constant term, okay? So this is how for different cases, you see that there are so many different possible regression equations we can actually derive from just one equation where we have used all these different types of dummy variables. So this is the idea. This is why we call this regression equation using all these dummy variables. We call it reduced form equation. And from this equation, we can unpack and unbox so many other equations. So that is the idea of it. Now, having said that, it is really convenient because, we really can sort of get so many different equations from one equation. But then the cost is that we have the slopes constant. Now, can we really have the slope constant? We cannot, and we have seen it previously that if you run a regression for different subpopulations, you are actually going to get different regression equations. So different with, with the slopes for other explanatory variables being different. So we need to sort of understand why it is happening. And in the next lecture, we are going to talk about the slope dummy. We have been talking about intercept dummy, but in the next lecture, we are going to talk about slope dummies. And with this, we end the lecture here. Thank you.